How to design a stackable guide in co-diagnostics. Let's look at the final plan-in result using this case as an example. We will start with extracting tooth number 37. Then we'll open the flap, connect position guide with the bone reduction guide and place it in the mouth. Insert the pins, then remove the positioner guide, but leave the bone reduction guide with the pins. Extract the teeth. Perform bone reduction. Connect the drill surgical guide with the bone reduction guide, then install the implants. Remove the drill surgical guide, install the abutments, connect the prosthetics with the bone reduction guide. Connect the temporary coping with the prosthetics. Remove the prosthetics, pins and the bone reduction guide. Finalize the prosthetics in the lab. We start a new case with the AI assistant by clicking Provide Data. Then go to step number 4 and select the model scan. In this case we have intraoral STL scans. Click on Align using AI Assistant and then select Mandible and click on Provide Data. Here you can see the AI Assistant icon with an orange hourglass. When this icon turns green with a check mark, you can import your selected data. Click on the AI Assistant icon to review your data. 3D objects, patient coordinate system, and panoramic curve. Check and correct the nerve canals right and left if necessary. Check scan alignment. And click on Import Reviewed Data. If you designed your mock-up in the CAD software, you could easily import it in co-diagnostics. Click Load Model Scan and select your mock-up data. Choose Copy Alignment and then click Finish. Your mock-up data is now transferred from the CAD software and placed in the same coordinate system as in the CAD planning. Install the implants. If you missed this step, please see the basic training. Once the implants have been selected and the abutments are installed, you can adjust the angle between abutments. Use this button to check current angle and acceptable deviation. Adjust if necessary. Select abutment, click on Change Abutment and then Data Set Alignment. Now you can rotate the implant around its own axis and ensure the position aligns with prosthetics and acceptable deviation. Once all angles are adjusted, you are ready to design the cut profile. Go to the plus menu and select Cut Profile. You can turn on the patient coordinate system for better orientation. Align your cut profile with the occlusion plane and make adjustments. Click Add Implants Base Points to match the cut profile with the implant positions, and then extend the cut profile out of the bone. Ensure the cut profile line is smooth to avoid sharp angles. Review the future bone reduction line. If your mock-up will be used as a temporary restoration, adjust the cut profile accordingly. Use points on the cut profile line to modify bone reduction line. Go to the AI models, select Mandible and click Edit Mesh. Choose the bone reduction simulation, select Cut Profile and click Execute Simulation. Review the simulated bone reduction. It is recommended to use Repair Mesh to reduce errors in STL file and make it lighter. Save as a copy. Turn off the AI models to view the lower jaw with the simulated bone reduction. Now we are ready to design the surgical guide. Go to step number 7, select the mandible jaw and choose the bone reduction option. Adjust the insertion view and proceed to the next step. In this step you can extend or modify the position of the pin sleeves. Make them a bit longer for stability. Proceed to the next step. Adjust the parameters of oral and vestibular sides of the bone reduction guide. If there are unnecessary areas within the guide, use the inspection window to clean them up. Click Next. Review your bone reduction surgical guide and apply changes. For the next step, convert designed surgical guide into a 3D model. Go to Edit Mesh and remove unnecessary areas. Then click Apply. Return to step number 7 and select the Bone Reduction Surgical Guide, a base. Adjust the insertion view again and design the drill surgical guide. Make the holders slightly larger and add support areas, ensuring they are outside the guide where there is no bone area. Add stabilization points for the surgical guide as needed. As an option, you can use large connectors option. Proceed to the next step and use the inspection windows from the bottom part of the guide to ensure connection. Engrave rotation markers. Finalize the drill surgical guide design, then apply the changes. And this guide fits perfectly on the bone reduction guide. However, if you're not satisfied with the design of the surgical guide, you can create a helper guide to improve it. For additional adjustments, go back to step number 7 and design parts to connect the first surgical guide. This step is optional. Create only parts as you want to connect with your first surgical guide. Now we can delete the inspection windows. Click Next and then click Next again. Now we have in the planning 2 guides. We can rename one of them as a helper and convert it into a 3D model. Open previous surgical guide and click Back. In this step we can see the Add Object option, select the Helper Surgical Guide and click Next. Now we can see that the Helper Surgical Guide is aligned with the main surgical guide. You are free to design your surgical guide and adjust it as needed. Now we need to design the positioner guide. Tooth 37 will be extracted because it is on the way of bone reduction guide. To extract this tooth I use the virtual tooth extraction function. Extract the tooth, click Cut with the dental alveolus and click Next. Turn off the original model and open the model with the extracted tooth in the mesh editor. Then I select the Combine function to merge Bone Reduction Surgical Guide with the model. Now we need to merge these two objects because we need support on both the teeth and the Bone Reduction Guide, while the Bone Reduction Guide will be based on the bone. Using the cutting tools, we can virtually open the flap. Roughly erase the area where the soft tissue crosses the surgical guide. Merge objects and click Save as Copy. Go to the Guide Design step again and select the last created STL object as a base. Click Next. Adjust the insertion view. Turn off the sleeves of the implants, but leave the sleeves of the pins. Select the area of the teeth and make necessary adjustments. You can use the draw function to make the guide more stable. Extend the position of the sleeves and add some support on the lingual side. Then click Next. Optionally, use the large connectors. Use inspection windows to see how precisely surgical guide fits on the teeth. You can cut the fitting areas from the bottom side of the guide. Click Next. And then click Apply. Now you can see the positioning surgical guide. To install this guide, you should extract tooth number 37, then open the flap. Connect position guide with the bone reduction guide and install them in the mouth for the first drilling. Insert the pins, remove the positioner guide, extract the remaining teeth, perform bone reduction, install the drill guide and place the implants. In the next step, we need to connect the prosthetic with this bone reduction guide. For this, I open the Mockup in the mesh editor. I use the eraser tool to reduce unnecessary areas. Now I click Repair Mesh. Select Boundary Optimization and choose to close holes. Save as Copy. Now my prosthetic is located in the correct position and does not cross the frame. We need to connect this prosthetic with the bone reduction guide. To do this, I open the mesh editor. Using the Draw Margin Line function, create a connection area on the bottom part of the prosthetic. Then I click Cut Mesh along the margin line to isolate this section and create a new object. Then click on Invert Mesh. With this new object, we proceed to combine it with the bone reduction guide using the Merge tool. Select the bone reduction guide as the base and combine it with the newly created object. Save the combined model as a copy. Now go to the Guide Design step again and select the new STL file as the base. Adjust the insertion view. Turn off the implant sleeves but extend the pin sleeves for better stability. Select a specific area, make it smaller on the bottom part of the prosthetics. Now we design the parts that will connect with the initial prosthetic. Open these seats with inspection windows. Then I click Add Object and select Modified Prosthetic Design. Now we can see prosthetic with designed connectors. Click Next, and then click Next again. Click Apply. At this stage we need to design holes for the abutments. Click on this 3D object and convert it into a 3D model. Then select Convert to Model. Click on the abutment and create New Implant Analog. Extend cylinder height. We can save this configuration as a preset. Click OK. For the next abutments, we don't need to design cylinder again, just simply select this preset. Click Next and then Next again. Now you can see your prosthetic with the holes. And all stackable parts are completed with their design.